Jai Hind everyone. I am Shraddha Mishra, Assistant Professor, Department of Information Technology, Ajay Kumar Garg Engineering College. Today, we will be starting our new series of lecture on the subject Discrete Structure and Theory of Logic. Our first unit is Set, Relation and Function. And there is a part 2 to it, lattice, which we will be covering in the next lecture. So, let's go ahead. Set, relation and functions. So we all must be aware of what do you mean by set, relation and function. We've all studied it in our class 11th and 12th NCERTs. So this is a quick brush up of those same concepts. In unit 1, we will mainly focus on lattice, but let's quickly brush up our concepts here. So set. In real life, what do you understand by set? Set is a collection of finite objects. For example, if I say there are infinite stars in the galaxy, so the collection of those stars, can I call it a set? No. Set is a collection of finite objects. So if I say that there are the collection of Bollywood actress, so it's a finite collection, I can call it a set. If I say that the students who have scored above 90% in this section, so there are a finite number of students for that. So the collection of those students is a set. But if I say the collection of water droplets in the ocean, or if I say that amount of dust accumulated in this room, these are something which we can't calculate, so they don't form part of set. So set is an unordered collection of distinct objects called elements or members of the set. The distinct object means every object is existing in itself and is unique, and it can be unordered. It is just the raw data. A set is said to contain its elements. Sets are used to group objects together. Often, but not always, the object in set have similar properties. So, if we talk about a set, it just needs to be existing set, right? It needs to be of the finite number of objects. So, it's not necessary that if I say that the only collection of red pens in this box is a set, right? For example, there is red, green, blue, all the colors of pen, and I am keeping it in a box and I'm calling that a set. So it's not necessary that in a set, the objects has to be of the same type. They can be different categories. For example, not just a stationery, for example, pen comes from stationery. We can also have, let's say, we have a chocolate, we have a toffee also in that box. So for example, I have a box and I call that a set. And in that box, I have 5 pens which are red in color. I have 2 pens which are green in color. And I have 2 5-star chocolates. And I might have a chalk. And I might even have a gold ring in that. So here we have all the different type of elements. But all of these objects, they are finite, they are distinct, they exist. And so that collection can also be called a set. Now, an object can be numbers, alphabets, names, etc. The idea of set theory is to turn logical predications like x is less than 100 and x is greater than 1 into object which can be manipulated by good formal rules. Set theory is important because it's a theory of integers, model of axioms, infinite ordinals and real numbers all in one unified structure. Let's understand it with the help of an example. Examples of set are set of natural numbers, set of rivers of India, set of vowels in English alphabets. We broadly denote a set by the capital letter A, B, C. A is a set and A is one of the elements of capital A. So, if for example, if we ignore case sensitivity, so small a, small b, small c, we can have it in one set and also we can have capital A, B, C also in the same set, right? So, now let's understand with the help of example. For example, here in this set you can see the elements are 1, 3, 5 only, but the frequency is different. Like 3 is repeated for 3 times, 5 is repeated for 4 times, but it is same as set 1, 3, 5, right? So here we say that these two sets are equivalent. Now, Two sets are equal if and only if they have the same elements. We write A equals to B if A and B are equal. Equal means the frequency and the element names have to be exactly same. For example, 135, I can write it in any order. 3, 5, 1, these are same because 3 and 3, the cardinality means the number of elements in that set. So here also we have 3 elements, here also we have 3 elements, but the order is different. So they are equal. Now here, if you see, this set is the same as the set 135, but the frequency of element is different, so that is equivalent, but that's not equal. A set is said to be an infinite if it is not finite. Now, set representation. So there are two forms to represent a set: roster or tabular form and set builder form. Roster or tabular form means inside the curly bracket, we write the elements separated by the comma. Set builder form means we write it in the form of an expression. So roster or tabular form, here you list these elements within braces. For example, if A is set of all odd numbers less than 10, so A is 1, 3, 5, 7, 9. Set builder form, for example, I say that the number of students in the class who have scored above 90% and are below 25 years of age, between 25 and 18 years of age, so those students, right? So if we have this word expression, we convert it into another expression, that is your set builder form. For example, it is given us in roster form 1, 3, 5, 7, 9. So what do you decipher from it? That these are odd numbers, right? But not necessarily prime. If had 9 not been there, then we could have said that it's a collection of prime numbers. So we could have written expression accordingly. So since we understood this is set of odd numbers, we have to convert it in the form of expression. So x is x equals to 2n minus 1, where n, cn and n less than 5. So similarly for this, we have another expression. So how do you write set builder form? It consists of 3 parts. First is x, which is always there, the variable you are talking about, you will be expressing it in colon. Then there is the second part. Second part means x is 2n minus 1, which is the formula, whatever you can decipher from it. And the third part is with the comma, which is usually the condition. So how I call it? The variable, the formula and the expression or the condition. So variable, expression and the condition. So in this variable, expression and the condition, it's in the vec form, variable, expression and condition. So if you are good with this formula, you can convert any roster form into a set builder form. So similarly for here, x colon x is 2 की power n, where n belongs to n and n is less than 5. Okay. So now we head to our next slide. Now let's understand the meaning of these symbols. So x belongs, so here this symbol which you can see in the form of E, it is actually more curly. So that is actually a symbol of belongs to. X, how do you read it? X belongs to A, or X is an element of set A. X, G, A, X does not belong to set A. B, empty set. Universal set. N, the set of all natural numbers. Then I is set of all integers, or Z. Z naught is set of all non-zero integers. Z star or I star is set of all positive integers. C, CO is a set of all complex, non-zero complex numbers. Q, Q naught, Q plus stands for the sets of rational, non-zero rational, positive rational numbers respectively. R, R naught, R plus is a set of real, non-zero real, positive real number respectively. So these are the meaning of the symbols. Now cardinality. Cardinality in plain word means number of elements inside the braces. So the total number of unique elements in the set is cardinality. For instance, if we see here k elements, they count to 4. So cardinality n of p is 4. It is denoted by n of p. And it has to be countable. So as A is a set of all non-negative even integers, which is infinite, as A is countably infinite set, and so the cardinality. Next, types of set. Singleton set, as the name says, single element in the set. So if you see this condition, x belongs to n, where x has to be between 7 and 9. So there is only one natural number between 7 and 9. Hence, it's a singleton set, which is 8. Null set or empty set mean there are no elements in the set. So we denote it by, inside curly bracket, we write no element. Subset means, for example, you have this set of 4, 2, 1, B, and you just count 1 and 2 element of that. So that is a subset of that, the derived set from the main set. So if every element in set A is also an element of set B, then A is called subset of B. Every set is a subset of itself. This is very important, that every set will be a subset of itself, because it will definitely have those elements, bare minimum, will be there by default in itself. The null set, that's phi, is a subset of every set. Like I said, if you talk about these two braces, so inside that by default there is phi which is there in that. Any set is never blank, there is always phi there in that. If A is a subset of B and B is a subset of C, then A will be subset of C. Finite set having n elements has 2 to the power n subsets. For example, there are 4 elements k, l, m, n in set A. The 2 to the power 4, right, will be the number of subsets. Next is proper subset. Proper subset means that if the elements are like B is the master set, right, which is your main set 1, 2, 3, 4, and the derived set, which is the subset 1, 2, has element comparatively lesser to it. Even if it's one element less, it has to be less, right? They say that because you've been my student, so of course I am the teacher, right? So here this teacher definitely has more knowledge compared to the student, right? So that's a proper subset. And improper subset means if A is a subset of B, then A is said to be an improper subset. For example, if you see, it's an improper subset, either they are equal or, so every set is an improper set of itself. So improper set means if they are exact equal, right? A student teaching another student in the class, right? They both are at the same level. That's an improper subset. There's some misbalance here. The proper subset means there is, it's in proportion, right? That, for example, there are 6 elements in the main set A, but the B is having only 2 elements. So that is a proper subset, because only then we call it a subset. No, had there been equal number of elements in both the set, then what was the difference to call it a subset? It's actually that own set. So that is an improper subset. Infinite set. So infinite set, there are infinite number of elements in that set. So countable infinite means that there is one-to-one correspondence between elements in the set and element A. A countably infinite set is also known as denumerable. Uncountable infinite means a set which is not countable is called uncountable infinite set or non-denumerable set, or simply uncountable. Example, set R of all positive real numbers less than 1 that can be represented by the decimal form 0. So in that case, it is an uncountable infinite set. Now, equal sets, equivalent sets. So like I said, give you an example of equal set. So equal set means exact elements are same. For example, there is 1, 2, 3. In the other side, there is 3, 2, 1. So the elements are distinct. They are exactly same, and the count is also same. That is equal. Not just the face value of the element is same, but the count within the set is also same. Okay. Here you have 1, 2, 3 in set A. In the other you have 3, 2, 1. So the elements are more or less 1, 2, 3 only, and the number of elements in the set are also 3. So cardinality is also same, and the distinct elements are also same. So that is your equal set. Exactly. Equivalent is more concerned with cardinality. Okay. For example, you have a set KLM, other you have ABCD, ABC. So 3 elements in each set, but the elements don't map to each other. They are very distinct. So in that case, that's an equivalent set, but it's not equal. Disjoint set. means they are absolutely having no connection between them. One is for numbers, another is for alphabet. Power set. Power set means how many subsets you can, how many power sets you can derive. For example, let's see. The power of any given set A is the set of all subsets of A, right? So, all whatever possible subsets you can form from the master set, from your main set, as many subsets you can form, and you club all those subsets together, that forms the power set. So, A is 1, 2, 3. So, by default, 5 will always be part of the set. Then 1, 2, 3 in itself. Then so one element, then we make pair of 2, 2, 2 each, then 3 together. So 2, 2 each means 1, 2, 1, 3, 2, 3. Or possible combination, the finally is 1, 2, 3. So this is actually not G, this is actually 5, right? So these very elements. 3, 2 to the power 3 means 8. So it is having 1, 2, 3, 4, 5, 6, 7 and 8. So 8 elements in its subset. That's a power set. Venn diagram. So, Venn diagram is a pictorial representation of sets in which an enclosed area in the plane represents set. So, if you have any enclosed area and you are representing set using that, that is a Venn diagram. This is very important from exam point of view, both for competitive exams and for AKTU. So, if you see here, you can see this is the common area between A and B, this is common area between A and C, this is common area between B and C, and this portion which you see here is uniquely for the area which is common for all the three A, B and C. So, let's understand union of sets. This is union. As the name says, the cumulative set. Intersection of set is this, intersecting portion only. Difference of set means excluding that portion, whatever is the residual. For example, if you see, how do you express it? A minus B. X such that X belongs to A and X does not belong to B. So, this is how you express it. Difference of set using A minus B. So, if you see here, you can see A is 1, 2, 3, 4 and B is 3, 4, 5, 6. Right? So, A minus B means A elements से हम B elements को हटा रहे हैं, हम माइनस कर रहे हैं ना. A में जितने एलिमेंट्स है उससे आप B को सब्ट्रैक्ट कर दो, तो जो भी रिमेनिंग एलिमेंट बचेंगे दे आर सेट A, राइट. सो इफ यू सी हियर A 1, 2, 3, 4, you subtract 3, 4, 5 means 3, 4 are which are part of B, you remove these, what remains is only 1 and 2. So 1 and 2. And similarly from B you remove A elements which is 5 and 6 which only remain. So here we have to denote A minus B. So you can see A minus B is 1, 2. This is the area which we have denoted. Next, complement of a set. So this entire universe is a set, or let's say our Mother Earth. Now here there are people, there are different types of living objects and non-living objects also, and they together form a huge set. Or let's say in simple words, 70% water, 30% land. So if I say this together form the set which is your earth, and I say that this 30% land is a set, so what is its complement? So complement is the one which completes it to make it one, and one is our Mother Earth. So that is 70% water. So if to the 30% land you add 70% water, only then it forms a complete set, Mother Earth. So here, if I say what is the complement of land, then it is water. Similarly here, this is the entire universal set. This is set A. So if you remove this set A, so this entire residual area is its complement. How you represent it? Universal set minus A star or A dash, X such that X belongs to universal set and X does not belong to A. So here you can see, let U be the universal set of all natural number. A is 1, 2, 3. So complement of this natural number will be all natural number except 1, 2, 3, because the universal set was set of all natural numbers. Symmetric difference of sets. The symmetric difference of two sets A and B is a set containing all the elements that are in A or B but not in both. So symmetric difference means Symmetrically, we will take the difference like A union B is this portion entire and B union A is this portion entire. But this is the portion which is common to both. So if from this union we cancel it from both sides, then this intersection is the one we will remove and it remains. So we can also write that A union B minus the intersection. So union से अगर हम intersection वाला portion हटा दे, that is symmetric difference. So what is symmetric difference? Means that from the entire union of set, if you remove the intersecting portion, that is symmetric difference. Let's see, head to the new slide, algebra of sets. So these are the major laws. Just throughout discrete structure, throughout DSTL, these laws are going to help you time and again. So idempotent law, associative, commutative, distributive, De Morgan, identity, complement and involution. Idempotent law means A union A is a set with itself. Associative law, A union B, if you keep the bracket here and you pull these bracket, you put it to next, still it's same, that is associative, irrespective of association. Commutative means back and forth, it's same, A union B same as B union A. Distributive, as the name says, about distribution. This A you distribute to both of this, it is A union B, union A union C. De Morgan's law, A union B complement is A dash intersection B dash. This is important. Identity law, A union phi is A. Any element which will help us get back to the same element. Abhi A, if you've done union with phi, it will give you the same element A. You have done union with U, it has given us again the universal set. So that is identity law. Complement laws, A union A dash is U. Involution law is A complement to complement is A. So it just neutralizes. That is involution. This is again important. Now, multisets. Multiset is an unordered collection of elements in which the multiplicity of an element may be 1, more than 1 or 0. So these are multisets. Multiplicity of an element is number of time element repeated in the multiset. For example, 1, 3, 3, 5. So 3 repeats 2 times. Whatever is the frequency of 3, 2, that is its multiplicity. Cartesian product of set. Like you can see here, there's one set P, there's another set Q. If you multiply it, so the number of elements are also multiplied. So let's see here. Now we come to the next part, which is relation. So relation between sets. Relation may exist between objects of the same set or between objects of 2 or more sets. So whenever sets are being discussed, relationship between the elements of the set is the next thing that comes up to our mind. Relationship between elements of more than 2 sets arise in many contexts. These relationships can be represented by n-ary relations, which are a collection of n samples. Now here you can see, let's understand with the help of example. Binary relation. Let A be the set 1, 2, 3, 4. Which ordered pairs are in this relation? R. So relation is given to us by this expression. And the relation says that AB, where A divides B. So out of this set A, 1, 2, 3, 4, we have to jot down those elements within the curly brackets where A will divide B. That means 6 will okay. So A divides B. So here this is A which divides B, right? So this is the expression. So accordingly we will have these sets for it. 1, 1, 1, 2. So 1 will divide its 1 will divide 2. So A will divide B. So 1 will divide 2. This 1 will divide every element, but obvious. 2 will divide itself, 2 will divide 4, 3 will divide itself, 4 will divide 4. But there's no way that 3 will divide 4. So it's not part of the set. These are relations. Then there are 2 parts, domain and range. So domain is, the domain of relation R is a set of elements in P which are related to some elements in Q. In simple words, if you have this expression as the relation So the domain are the first element of each of these set. That's a domain. Okay. And the range are going to be the second elements in the layman language. So domain basically means if you have these two sets X and Y and A, B, C as the elements in this and P, Q, R as the elements on this. So A maps to P, B maps to Q and C maps to R. So these all are the domain here, right? These A, B, C part of set X, because they are the one mapping to the another set P. So these are the domain and range. Inverse of a relation. So very simple, as the name says, whatever expression you have, you invert each element to it, you will have the R inverse. Okay. Next is reflexive relation. Reflexive means those relation where they are part of themselves, like 1, 1, 2, 2, 3, 3, 4, 4. So they may have multiple relations, but a relation with itself, if you are reflecting to yourself, that is your reflexive relation. Then irreflexive is the residual ones which were not mapping to itself. Symmetric relation, right? 3, 3. So 3, 3. So reflexive is definitely symmetric. So symmetric relation you can understand here. For example, if you see this set A and they have given us this relation from this set, is this relation R symmetric or not? The relation is symmetric as for every A comma B. We have B comma A, which is 1, 2, 2, 1, 3, 2, 3, this, which are part of this set. So in relation, you have to prove whether it's an equivalent relation or not. Equivalent relation means it has to be reflexive, symmetric, okay, and transitive. So here in this case, if you see reflexive, antisymmetric and transitive are equivalent, but what we are understanding here is the reflexive, symmetric and transitive ratio. So reflexive means if the relation which is given to you, it accumulates or it has all the elements which map to itself, then it is reflexive relation. Symmetric means if that relation has all the elements back and forth, they are same, then it's a symmetric relation. For example, if you see here 1, 2, 2, 1, 1, 2 है तो 2, 1 भी होना चाहिए. Is it in the relation? Yes, 1, 1, 2, 2, these are reflexive by default, so that is there. तो 1, 2 है, अगर 1, 2 है उस relation में, तो 2, 1 has to be necessarily there, only then it's a symmetric. Yes, it is there. अगर 2, 3 है, तो क्या 3, 2 है इस relation में है, तो it is a symmetric relation. अब extra कुछ है नहीं है, we are least interested. So what we are interested in is that those elements are there in that relation. Next is antisymmetric. Antisymmetric means that those elements are not there. Right? अगर 3, 2 है तो 2, 3 नहीं होना चाहिए उस relation में. Then that's a antisymmetric. Asymmetric, transitive relations. Now identity relation and universal relation. So identity is again with itself. Okay. Equivalence relation is reflexive, symmetric and transitive, not antisymmetric. Okay. So if you see here, next topic is function. So what is an equivalence relation? Equivalence relation means if a relation is reflexive, and symmetric and transitive, it's a symmetric relation. Next is function. So function assigns to each element of a set to exactly one element of a related set. Domain and codomain. Let's understand here again, like I told you, this is domain, the first part of the set, and the second is range. So when this elements of this set map to the element of the other set respectively, so these elements of the first set are called the domain and the other are the range. So 1, 2, 3, 4 here are the domain, range are A, B, C, D, codomain are A, B, C, D, E, right? So codomain is everything which is in set A is your domain, everything which is in set B is your codomain. Range means those elements which are participating in the exact mapping. 1 का दोस्त है यहाँ, yes, B. 2 has a friend A. 3 has a friend D, and again 4 has a friend C. But E bichara अकेला है. So E doesn't have any friend, so it will not be part of a range. So range means the one where every element of the other set has a mapping to it. Injective function definition: a function f is 1 to 1 or injective if in this case you can see, so 1 to 1 means, as the name says, 1 to 1 सबका एक एक mapping है यहाँ पर for the set A, not necessarily for set B. Injective, like injection. How do you do? We do the injection. So from our end, we are injecting the vaccine into every person. Now, are they receptive to it? It's their call. Now, what here we have done A, B, C, D. At least set A में हमारे सब दोस्तों को एक एक partner मिल गया है, right? So here you go to a party. So all of these friends, they have a friend to dance with. But ये बेचारा V is alone left. So in this case, what do we say? That it is injective because set A at least has the mapping. Surjective function. Surjective means it is onto or surjective, right? So if you see here, A has a friend Z, B has a friend Y, C has a friend X, but D is having, so Z is having two friends. It's taking money from A also, taking money from Z also, right? So in this case, what we are going to do, so Z has two friends. Z is too friendly. That is a surjective function, right? Because there exists exact mapping to each other. It's onto mapped. Not necessarily if there are two friends for one, that's not an objection, but each has to be correspondingly mapped. कोई अकेला नहीं छूटना चाहिए. Neither से both parties are happy. That is onto, surjective. Bijective. Bijective means a function f is a 1-to-1 correspondence or a bijection if it is both 1-to-1 and onto. Bijective means it is 1-to-1 also, it is onto also, then it is bijective. Inverse of a function means A is f inverse B, so B is f of A. That is inverse of a function. Then composition of functions. F, so here you have A, this is your function G and this is your function F. So you have this set A, you have this set B, G here, F here, then you call this as fog of A. So G, so it is in contrary, fog में हमें लगेगा F is first, G is second, no. But when we talk about fog of A, means G is first and F is second. So that is called as fog. That is composition of function. You superimpose these elements, you map them to each other. The composition here means that this function A to B, B to C means A, B, C से related है. कैसे? F of G of E से. Thank you so much. Have a great day. Hope you enjoyed. Thank you.